Hello everyone, we are discussing circular motion and so far we have developed concept of angular displacement, angular velocity and angular acceleration. First, look at this part. An object is moving in this direction, then direction of angular velocity is this dot. Angular displacement, angular velocity, angular acceleration, all these are called axial vectors. Their directions are always along the axis. This is the axis of rotation. And that's how you give the direction of all these vectors. How do we do that? We have discussed these things before. And in the previous class, we also developed this relation, which is V equals to R omega between tangential velocity, linear velocity, and angular velocity. At the same time, we also developed a relation between A and alpha, where A is R alpha. This is your V. What is the direction of this velocity? This velocity is along the tangent, and therefore we will call it tangential velocity. This is tangential velocity, this is angular velocity. This is tangential, so what is A? It's now easy to remember. A is angular, A is tangential acceleration. So this A, remember, is tangential. This alpha is angular acceleration. We have already done these things. Now, look at this part. Everybody has seen these equations. V equals to U plus AT. V square U square plus 2AS. S equals to UT plus half AT square. Everybody knows about these equations. These are Newton's equations. We use these equations when A is constant. In circular motion, you will replace these things in this form. What is V? Final velocity. Make it omega final. What is U? Initial velocity. Call it omega initial. What is A? Acceleration. Call it angular acceleration into T. This is kinematics, motion in 1D. This is circular motion. This omega final square, omega initial square plus 2 alpha. What is S? Displacement. It becomes what? Theta, which is angular displacement. Last one. What is S? Displacement. It becomes what? Theta. What is U? Initial velocity. It becomes what? Omega initial T plus half alpha T square. So this was something which we established in one-dimensional motion. This is for the two-dimensional motion, which is circular motion. So you need to remember what? This is linear velocity, this becomes angular. This is acceleration, linear, it becomes angular. This is linear, linear means straight line. Linear displacement, it becomes what? Angular displacement. And the important part, these equations are used when A is constant. These equations should be used when alpha, the angular acceleration part, is constant. Put down this as well as this, and then we'll solve a few questions. You can simply remember this U, it becomes omega initial, V, it becomes omega final, A, it becomes alpha, S, it becomes theta. That's the only thing you need to remember. I'll write down the question. An object is moving in a circle such that its angular acceleration is constant. Such that its angular acceleration is constant. Initial angular velocity of the object, initial angular velocity of the object is 20 radians per second. which after 10 seconds becomes 50 radians per second. Question says that alpha is constant, an object has initial angular velocity of 20 radians per second, and after 10 seconds it becomes what? 50. Now complete the question. Find out number of rotations made by the object. Number of rotations made by the object. Let's see how many of you can answer this question. We've got 1 minute's time. Well, we got only one response. Look, question says find out number of rotations. Then when I say number of rotations, what is the relationship between number of rotations and angular displacement theta? Number of rotations and theta. A very easy task. If an object completes one rotation, then what is the angular displacement? 2 pi. One complete circle. What is this? 360 degrees or 2 pi. For two rotations, angular displacement will be what? 4 pi. And therefore remember this, theta is what? N times 2 pi. Relationship between angular displacement and number of rotations. Now the question which we are solving requires n. What is n? Theta divided by 2 pi. That means the question which has been asked gives us omega initial, gives us time, gives us omega final, and when it asks us find out n, you need to just find theta, divide that by 2 pi, and you'll get your answer. So how do you find theta? One way of finding theta is we have the value of omega final, we have the value of omega initial, time is given, we can calculate alpha. And the moment you calculate alpha, put it over here or in this. If you put it in this equation, omega initial is known, t is known, alpha is known, and you will get your answer. This is one way of answering this. But if you remember kinematics, then in kinematics we had an equation which relates u, v, t and s. Let's see how many of you can write that equation. What is the relationship between u, v, t and displacement s? We've got 10 seconds time. If you remember the result, relationship between s, u, v and t, provided A is constant, was this. No, not this. Just a second. This. U plus V divided by 2 multiplied by time. This was the relationship. I hope you remember. But only if A is constant. In case you forgot this, then remember this part u plus v by 2. This is called average velocity. Not always, only if A is constant. What is average velocity always? Displacement divided by time. Well, we have done these things in kinematics. This S becomes what? Theta. U becomes omega initial. V becomes omega final divided by 2 multiplied by t. This is the circular motion equivalent of this equation, provided alpha angular acceleration is constant. Which means you know that. What is this term? This term inside the bracket, it will be called what? Average angular velocity, provided alpha is constant. Now, once you know this formula, how easy it is to answer the question. What is omega initial? 20. Omega final 50. 20 plus 50, 70 by 2, 35 into t, 350. So 20, 50, 70 by 2, 35 into t, 10. So your theta is coming 350 divided by 2 pi, and that's your answer. Note down this. And if you understand the whole thing, then write down yes in the comment box. Write down the next question. A table fan, when switched off, a table fan, when switched off, stops after 20 seconds. A table fan, when switched off, stops after 20 seconds with an angular retardation of with an angular retardation of 5 radians per second square. This is a table fan, you switched it off and then it slowly comes to rest after 20 seconds. And this is the angular retardation which it experiences because of friction and all. The question is, find out number of rotations it made before it comes to rest. Find out number of rotations table fan makes before it stops. Let's see who can solve this question. Look, we have been given time which is 20 and they have given us stops. That means they have given us omega final, which is 0. It was rotating with certain angular velocity. We have no idea what was that, but question says it stops after 20 seconds. So omega final is what? 0. And angular retardation alpha. What's the value of alpha? Write down in the comment box fast. What's the value of alpha for this question? Stops. What is alpha? This much time is sufficient. I'm asking just to check whether you use the negative sign or not. Alpha is what? -5. Retardation. When you switch it on, alpha will be positive. You switch the fan off and therefore alpha is coming what? Negative. So one way of answering the question will be what? You have omega final, you have the alpha, you've got t. With the help of this you can find omega initial and that will give you, and then after that you can use this equation S. That's how you read it. S equals to U T plus half A T square. S equals to ut plus half at square. You can find omega initial with the help of first equation. First equation, V equals to U plus A T. We have omega final, we have alpha, we have T, we can find omega initial, put it over here. Find out theta, use this, and then you can find N. This will be the first method, but I don't want to teach you this. I'm interested in this equation. Again, first let me ask you this part. If you know the answer, if instead of initial velocity we have been given final, instead of u, if we have been given v, then s equals ut plus half at square. It takes a different shape, different form. Write down that different form if instead of u we have been given v. Let's see how many of you remember this much. This is coming from kinematics. Good. If we are given initial velocity, then we use ut plus half at square. If we are given final velocity, then we use vt. Replace u with v minus half at square. When you replace u with v becomes final, and replace a with minus of a. So for us, the question is this, theta, what is v? Omega final, t minus half alpha t square. Just to give you an idea of this equation, I am giving you this particular question. What is omega final? Look how easy it is. Instead of using this equation first and then putting values in this, you can save a lot of time if you use these equations. So what's the value of omega final? Omega final stops 0. Done. Minus half. What is alpha? It's not 5. It is minus of 5. This negative sign is coming from the formula, and this negative sign is because of the retardation part. T is given as 20 square. Negative, negative, positive, 20 square, 400, 400 into 5, 2000 divided by 2000. So theta is coming 1000 radians. We are interested in n, which is 1000 divided by 2 pi. So number of rotations this fan makes before it comes to rest is 500 divided by pi. If you could not solve this question but you understand it, then write down yes in the comment box. And if you have any confusion, then just write down your confusion. Well, I see no response. What does it mean? You are confused, or do you understand this question? Write down yes or no. Good. Now write down centripetal force and centripetal acceleration. Centripetal force and centripetal acceleration. Well, those of you who are interested in its derivation, the formula which we are going to use, if you are interested in that, you will simply tell me after the class and I will give you the link. There are two methods and I'll send you both lectures where I have taught the way centripetal force is developed. Those of you who are interested in the way things work. For others, and in fact for everyone, you need to remember this. Let me ask you a few things. Object is moving with V and V is constant. V means constant speed. And this is the circle of radius r. This is the object of mass m. So you have an object of mass m which is moving in a circle of radius r all the time with constant speed. Does it have any acceleration? Yes or no? Does it have any acceleration? Yes or no? What is acceleration? A. What is this? D V by dt. What is it? Rate of change of velocity. Is V same? No. Only V is same. In circular motion, there is no way you can keep direction same. That means V is not same. This is correct. How do you read? V is same. Is it correct? No. V is not same because there is no way you can keep velocity same in circular motion. Continuously direction is changing. So if you are saying that V is changing, if V is changing, then A 0 is not possible. A can never be 0. So in circular motion, whatever you do, there is no way acceleration can be 0. Now, this is something which we did in the very first class, remember. And if you wish, you can write again because some of you answered no, and therefore write down the statement. And this is for everyone. This is total acceleration, by the way. This is total acceleration. And why is it total acceleration? Because I'm differentiating V. I'm using V vector. What is V vector? Magnitude as well as direction. So whenever you differentiate V, you get what? Acceleration. Write down the statement. In circular motion, acceleration can never be zero. Because direction of velocity continuously changes. Because direction of velocity continuously changes. Next line. If speed of the object is constant, if speed of the object is constant, in circular motion, remember, in circular motion, if speed of the object is constant, then tangential acceleration is zero. Then tangential acceleration is zero, and only centripetal acceleration is present. And only centripetal acceleration is present. So in this case, well, we have discussed this thing in the very first lecture. A quick reminder, when object was traveling like this with V, it had a tangential acceleration AT, it had a centripetal acceleration AC, and together these two give you what? This thing, A total, capital T. Small t for tangential, C for centripetal. This gives you what? A capital T. This AT changes magnitude of V. Constant speed का मतलब यहाँ पर AT नहीं है. AT is not there. And what AC does? You're moving this way, somebody is forcing you this way. You're moving this way, a force comes this way, will change the direction. So what AC does, it changes direction. And this AC, for proof, I have told you what to do. Remember, AC acts towards the center and is given by V square divided by R. And when those of you are interested in proof, the proof will come with the help of this dV by dt. Change, find the change, and you will get A. So before even looking at those lectures, if you want to develop this part yourself, you can do that. If you can find dV. For others, forget about this. What is AC? V square upon R. This is AC, centripetal. Then what is F? C. What is FC? Centripetal force. What is force? Mass into acceleration. M into AC, which is M V square divided by R. So this is your centripetal acceleration and this is your centripetal force. Note down this much. and this is your centripetal acceleration. When you have the constant speed, this AT will act in this direction and will be called what? AC. In non-uniform circular motion, this AT has two components, one is AC and the other one is AT. In uniform circular motion, this is called uniform circular motion when speed is constant. In uniform circular motion, you have got only AC part, means this is the only acceleration present. So this and this, they are the same thing. Now, write down the value of centripetal force in terms of angular velocity. You've got 20 seconds for this. Centripetal force in terms of angular velocity. So tangential is V. We know what Fc is, mv square upon r. But I need Fc in terms of omega. What is V r omega? What is the value of Fc? M V square divided by r. That is M. What is V? R omega. R square omega square divided by r. This gives us centripetal force as mr omega square. And for AC, what is AC? Force divided by mass, that is r omega square. Centripetal force in terms of omega, centripetal acceleration in terms of omega, and this is your centripetal force in terms of V. Note down this. Now, when FC is written in terms of V, its direction is towards the center. When FC is written in terms of omega, what will be the direction of FC then? Write down in the comment box. If FC is written in terms of omega, then what will be the direction of FC? When it is written in terms of V, direction is towards the center. When it is written in terms of omega, then what will be the direction of FC, centripetal force? Well, one of you is saying that my camera is off. Is it with everyone? Does everyone find the same thing? Or you can see the video? Okay. The person who cannot see the video, just disconnect and then reconnect. Well, for the question, I'm asking you what is the direction of FC. I'm asking you direction of what? Centripetal force. I'm asking you direction of a force which always acts towards the center. Look at the catch. The question was just to confuse you. Some of you, which I could see that they have responded that way also. So this is a common misconception that once it is in terms of omega, then it becomes an axial vector. No. We are giving the magnitude in terms of m or omega square. What is the name of FC? Centripetal, a force which acts towards the center. Always. You give its magnitude with V or omega, it doesn't matter. This is your centripetal force. It is acting this way only. So remember, even in terms of omega, it doesn't change the direction part. Now, let's understand the importance and role which AC plays in circular motion. Well, everybody knows that Earth revolves, rotates about Sun in almost circular path. The path is basically elliptical, and but for us, just say it's a circular path. So Earth is rotating about Sun in a circular path. Gravitational force of Sun is acting on Earth. What this gravitational force does, write down in the comment box. Who will tell me the role which gravitational force plays when Earth rotates about Sun, assuming that the path is circular? Then what is the role which gravitational force plays? Mention this in the comment box. Well, good. Everybody is answering the basic meaning, which is correct. So the question I am asking you is, this is Sun, and this is Earth. And Earth is moving in a circular orbit. So what basically you are saying is that the gravitational force which is acting on the Earth, F G, capital G for gravitational force. And maybe you have seen things like these. This gravitational force is G m1 m2 upon r square. We'll see this thing in detail when we handle gravitation. As of now, we don't have to worry about this. Forget this. हर आदमी को पता है कि सन अर्थ को अपनी तरफ खींचेगा, और आपने आंसर भी सही दिया कि अर्थ इधर जा रही है, ग्रेविटी ने इस तरफ खींचा, डायरेक्शन लगातार क्या हो रहा है, चेंज. तो डायरेक्शन है that is continuously changing. The answer is correct, but the way I want it is this. आप लोगों ने बोला ग्रेविटेशनल फोर्स डायरेक्शन चेंज कर रहा है, लेकिन मैंने आपको क्या सिखाया, कौन है जो डायरेक्शन चेंज करता है, सेंट्रीपिटल फोर्स. That means this gravitational force, it is nothing but centripetal force. Gravitational force, gravitational attraction of sun on earth, which changes the direction, is nothing but centripetal force acting on the earth. Write down this. When earth rotates about sun in a circular orbit, gravitational force of sun on earth provides necessary centripetal force. Well, चीज और अच्छे से क्लियर हो जाएगी. Just tell me, have you seen this formula before? Yes or no? If you allow me to use this, I can create a good question for you. Have you seen this formula gm1 m2 upon r square? Yes or no? Good. Now look at the question. उससे सेंट्रीपिटल की कहानी और अच्छे से आपके लिए उठ जाएगी. So we are trying to solve a question which is basically asked in the chapter of gravitation. But somebody who knows this, somebody who knows the concept of centripetal and all, they can answer this question. Everybody in the class can answer this question. Just don't leave it, give it a try. This is small m for mass of earth. This is capital M for mass of the sun. This is the radius, small r. Radius of the orbit is what? Small r. Earth is rotating with v. जब हम ग्रेविटेशन करेंगे तो इस v को हम वहां पर बोलते हैं ऑर्बिटल स्पीड. ऑर्बिट में रोटेट कर रहा है तो क्या कहलाएगा? ऑर्बिटल स्पीड ही कहलाएगा भाई. This is m, this is small m, this is r. Earth is rotating with v, the orbital speed. Let's see how many of you can find v. Don't forget this. And everybody can answer this. Just think about it. Technically, it will take just 20-30 seconds. But I'm giving you 1 minute's time. Find out value of v. So it will teach you why do we study all these things. Somebody who has a knowledge of gravitation, somebody who has knowledge of centripetal, he can immediately find things like these. And good, some answers are correct. So what I told you, capital M, which is sun, is pulling Earth towards itself with a force of gravity Fg, and this Fg is nothing but the centripetal force Fg, which is force of gravity is providing Fc, which is centripetal force. Gravitational force is providing us centripetal force. Fg is Fc. What is Fg? Here, G m small m, m1 m2 divided by r square is equal to what? Fc. What is centripetal force? M v square divided by r. M cancelled, r cancelled. Orbital speed is coming what? Root over gm by r. And some of you got this part correctly. So that's how you can find all these things. We can see that the orbital speed is root over gm by r. Note on this. So this is an example of uniform circular motion. Uniform circular motion. Gravitational force is giving us centripetal force. देन इसके फायदे क्या हैं? फिजिक्स को डेवलप करने का एडवांटेज क्या है? क्वेश्चन यह है आपके पास कि हमने अर्थ का जो मास है उसको डिक्रीज कर दिया. सपोज अर्थ somehow its mass is halved. You make it m by 2. If you decrease the mass by half, then what happens to orbital speed? You can expect something like this in circular motion or maybe in gravity. Let's see who will answer this part. If suppose mass of Earth is decreased by half, then what happens to orbital speed? गुड. तो अगर किसी आदमी को फिजिक्स का आइडिया नहीं होता, then he had to observe everything. If you have the idea of physics, centripetal, gravitational force, then you arrive at this, which says what? What is m? Mass of sun. And what I have asked you to change this m, which is mass of the planet. You can see that orbital speed is independent of mass of the planet. तो अर्थ होती या आप होते, आपका मास ज्यादा है या अर्थ का? अर्थ से आपको अलग कर दिया जाए तो आपका मास बहुत कम है, अर्थ का क्या है ज्यादा. लेकिन जो ऑर्बिटल स्पीड आपकी है वही ऑर्बिटल स्पीड किसकी है? अर्थ की. Did you get my point? हम भी सन के चारों तरफ चक्कर लगा रहे हैं because sun, its gravity is pulling on us. So as it pulls on this body, we are also making a circular path, which is uniform circular motion. But does it change our speed? The answer is no. Why? Because the object which is revolving, its mass is getting cancelled. Next thing we can ask you is this. Answer this part. बता भाई किसकी वेलोसिटी ज्यादा होगी, जुपिटर और अर्थ? Which one is moving with greater speed, Jupiter or Earth? For Jupiter, write down J. For Earth, write down E. Well, I hope everybody knows that Jupiter will be somewhere here. That's your Jupiter. तो Jupiter के लिए क्या ज्यादा है? Radius of the orbit. तो अगर किसी ने R को क्या किया? Increase. What happens to E? Decrease. Jupiter का mass, हमें क्या करना mass का? What is that? Mass of the sun. Orbital speed, it is depending only on what? Orbital radius. So as you move away from the sun, your orbital speed decreases. So the question can be that which planet is moving with maximum orbital speed? I hope everybody knows the answer. Write down the answer in the comment box fast. Which planet in solar system moves with maximum orbital speed? The one which is closest to sun. And what is that? Mercury. So, gravity, centripetal together, you can solve a question like this. I hope you understand the importance of all these things. Now, write on the next question. An object of 5 kg, an object of 5 kg is moving in a circle of, an object of 5 kg is moving in a circle of radius, radius 2 meters. With the help of a rope, on a frictionless horizontal table. It's a big table. Yeah, legs. It's a frictionless table, the horizontal one, and you have an object of mass 5 kg which you have connected with a rope, and this rope, in this rope, question says you need to find the tension force. The question is this. This is the object of 5 kg, length of the rope is 2 meters, and this is not the circular motion, this is called circular motion in vertical plane. We are interested in, assume that we have a horizontal frictionless table over here. Why do we need a table? So that the object doesn't fall down. So if you have the table, then the object will keep on moving. I hope itni akal hogi, feel kar pa rahe hoge. So this is how the object is moving. So object is moving like this in the horizontal plane. That's how. And question is, find out, when you rotate this thing, this rope is under the tension. What is the tension force? Answer this. And just in 10 seconds you can answer the question. In 10 seconds. Such an easy thing. इधर अगर ये रोप नहीं होती तो फिर ये ऑब्जेक्ट सर्कुलर मोशन नहीं कर सकता था. What is the force which is changing its direction? मैं थोड़ा वर्टिकल प्लेन में दिखा देता हूं जिससे कि आपको फील हो सके. अगर ये ऑब्जेक्ट मूव कर रहा है सर्कुलर पाथ में, then what is that which is changing the direction of motion? This tension force. तो जो टेंशन फोर्स है, अगर ये डायरेक्शन चेंज कर रहा है तो डायरेक्शन तो कौन चेंज करता है? सेंट्रीपिटल फोर्स. विच मीन्स इस रोप के अंदर इस ऑब्जेक्ट पर जो टेंशन फोर्स लगेगा toward the center. This is the center, this is the object. समझ में आ रहा होगा कोई बहुत खतरनाक सी चीज नहीं है. Center, object, tension. What about tension force? From laws of motion, you know that tension always acts away from the body. Away from the body. It's a pulling force. It's a pulling force. You cannot push, it will collapse. You can always pull. So this pull is acting towards the center. And what does it provide? It provides centripetal force. So question says find out T. हमने बोला ये जो T है भाई ये क्या दे रहा है? FC. I think I forgot to give you V. My fault. My mistake. Sorry. I forgot to give you V. Data is not complete. बचा भी कुछ नहीं है. V ले लो V को कुछ 10 meters per second. Maybe because of this you could not answer, no issue. So the logic is that this T which is acting towards the center is providing us what? Centripetal force. What is centripetal force? M V square divided by R. We have the value of M 5. V I just gave you 10 divided by R 2. This is coming 250 newtons. 250 newtons. If you understand this part, then write down yours in the comment box and then you can leave. Thank you very much.